Okay, GRE tunnel configuration. Run it through one more time because I'm too lazy to join videos together by software. I just really don't feel like dealing with it, so I'm just going to do it again. So I have the basic topology ready to go for GRE tunnel configuration. Uh, Very simple. Three routers, R1, R2, and R3, running over this 1010 and 1020 networks between the three. And the goal here is to configure a GRE tunnel. I kind of put a logical note up here, but I'd like them to use 172.16.0.0/30, and this tunnel should run from R1 to R3 using these loopback interfaces. All right, start them up. I should have done that while I was talking. Now we get to wait. Get to wait for router boot up, but that's okay. In the meantime, I can at least get this a little organized. All right, topology on the bottom. We have enough. We can kind of see what's going on here. Routers are booting up. I guess a good thing to note about GRE tunnels is it encapsulates pretty much anything to a unicast packet. So if you're using a routing protocol, it's communicating over multicast, it will take that multicast, throw it into a unicast packet, and send it over, which is great if you wanted to combine that with, say, IPsec. All right, configuration. We have R1. Let's go ahead and get the tunnel up. CompT interface. I'm going to use tunnel 100. IP address. Looking down here, it's going to be 172.16.0.1. It's going to be a /30, which ends in 252. We'll do a tunnel source. Looks like my OSPF just came back up. Tunnel source, loopback 0. And we'll do the tunnel destination as the loopback on R3, which will be 10.35.0.1. Again, heads up on this topology, it's all connected via OSPF. Assume all of these are routable. If you're sending a tunnel destination up with an IP address you can't reach, your tunnel is not going to function. All right, at this point, we have a tunnel configured. Let's do a show run. Interface, tunnel 100. That's all there is to it. IP address, source, and destination addresses. We can do a show and description, shows the tunnel is probably up. We can try to ping that 172.16, but we have not configured it yet, so pings will likely fail, which looks like that is the case. So on R3, we'll go ahead and just configure the tunnel. I'm going to use the same interface number, tunnel 100, IP address 172.16.0.2 in this case. Oop. Always helps to put a subnet mask. Again, that's going to be /30 ending in .252. Tunnel source will be loopback 0. And tunnel destination will be the loopback on R1, which in this case is 10.15.0.1. Refer to the topology below. There, interface tunnel 100 changed to state up. Right here. Should be good. So at this point, both tunnels are configured on R1 and R3. We'll run a ping between the two and make sure they're functional. Looks like ping works, but we'll run a trace route first, starting with the loopback just to show that it's hitting every router, multiple hops, and that the tunnel in comparison should be a single logical hop. So 10.35.0.1 is R3's loopback address. Hits 1010 over here and the 1020 over here, so 2 hops. But if we ping the tunnel address that we just configured, 172.16.0.2, we do get the 1 logical hop.